Hello, Physics Nation. My name is Nate Larmond, and I'd like to set up an experiment called vertically launched projectiles using hang time to find maximum altitude and launch velocity. So we're going to keep track of a vertically launched projectile. We can launch an apple, we can launch a marble, or you're going to jump. You're going to measure how long you're in the air. So start, stop, start, stop. Start the stopwatch when your feet leave the ground. Stop the stopwatch when your feet come back in contact with the ground. And then we're going to predict how high you can get off the ground. It's called your vertical leap, or in physics class, maximum vertical displacement. So it's a pretty simple calculation. Pardon my scrolling. Here's your hang time, the raw measurement. Cut it in half to find the apex time. So we are assuming symmetry. If you're in the air for a second, it's going to take you half a second to get to the top. But something magical happens at the top, right there. It stops moving right there. There is no velocity, so we're actually going to cut the action in half and just worry about the up half. You can also assume the acceleration is negative 9.8 meters per second squared because you're in free fall. Gravity is the only significant force acting on you. Here's the definition of acceleration, and the final velocity leaves. There is no final velocity. So that term drops out. We can multiply both sides by t, multiply both sides by -1, except the acceleration is already negative, so you end up with 9.8 multiplied by the apex time. Again, in my example, the apex time would be half of the total time. If you're in the air for a second, it takes half a second to get up. Half of 10 is 5 meters per second, roughly. So if this apple was in the air for a second, it left my hand moving 5 meters per second. But let's do a trick we've done before. If it goes from 5 meters per second to 0, we can say the average velocity is right in between the two because the velocity is constantly changing. So find the average velocity. In my example, that would be half of 5. That's 2.5. Okay, so if it takes half a second to get up, a quarter of a second after you let go, it's moving 2.5 meters per second. Then we're going to use the other average velocity equation. Average velocity equals displacement over time, except now we're going to multiply both sides by t, and we're going to find the vertical displacement. So average velocity multiplied by apex time is your predicted vertical leap. All right, so what would that be? 2.5 meters per second multiplied by half a second. Half of 2.5 is 1.25, 1.25 meters. Your vertical leap is not going to be 1.25 meters. Well, who knows? Maybe you are going to the WNBA or the NBA. I don't know. Anyway, then you experimentally measure your vertical leap. So we have the predicted vertical leap based on hang time. Then you're going to put a piece of masking tape on the wall as high as you can reach while your hand, that is, while your feet are still in contact with the ground. Then you're going to jump as high as possible and slap a second piece of tape on the wall. The difference between these two pieces of tape is your experimental vertical leap. That is your real y displacement. And we're going to do a classic percentage error calculation. We're going to do the experimental value minus the predicted, all divided by the experimental to find the percentage error. Thanks for watching. Happy jumping. See you in the next video.